One of the things I've been enjoying about making these videos is the feedback, which has been overwhelmingly positive even when it's critical. In this video, I'm going to discuss some of the very interesting feedback I got in my last video about optimizing code for the CPU cache. But first, I'm still looking for work in January of 2024. If you know of an opening that you think I'd be a good fit for, please use the link in the description to contact me via LinkedIn. Before I start, a few notes. First off, I'm not infallible. So please keep the comments coming if you feel I've made a mistake. One of the great things about making these videos is that sometimes I have to spend extra time being sure I understand something before making a video, which means I also get to solidify my own understanding. However, sometimes I still make mistakes, which means that my viewers will probably correct me. In either case, I get to improve my knowledge. A common criticism from the last video is that I don't use Go's built-in benchmarking tools for my tests. The reason is that I feel the benchmarking tools make the code less understandable for short videos like I'm making. The benchmarking system in Go is excellent, but it does some things automatically behind the scenes, and I don't want those to be hidden. One could make the argument that Go developers are familiar with the tools and thus won't be confused, and maybe that's correct, but it seemed less clear to me when I was making the videos. Given the feedback, I'll have to revisit that decision the next time I make a performance-related video. Another common criticism is that some tests make calls to the random number generator while other tests don't, thus the comparisons aren't valid. On the one hand, I carefully isolated the random calls from the collection of elapsed time, so that's not actually a factor. However, it is possible that the generation of random numbers pushed enough data around in the CPU cache to impact the results. I did a quick test by calling the random number generator in the sequential test as well, and got times very close to the original. So while the criticism was valid, it didn't end up impacting the results. An important point that I tried to make in the video, but want to re-emphasize here. Not all hardware is the same. It would be impossible for me to make specific recommendations about memory and sizing and that kind of thing, because on a different CPU the results may be different. The goal of that video was to show that there are techniques that can improve CPU utilization, not to attempt to define exactly how much improvement will be seen, which would be impossible anyway without running the experiments on every possible piece of hardware. One thing that wasn't so much a criticism as points that people made is that CPU cache is more complex than I made it out to be. Anytime I simplify something to make it easier to explain, I run the risk of simplifying it too much and thus making it outright wrong. I don't think I went that far in that video, but it's important to note that modern CPUs are complex beasts, and the way they move memory around is far more complex than how I portrayed it. By way of example, there are multiple memory caches of different speeds and sizes forming a cache hierarchy, which can have quite an impact on certain workloads. The CPU cache stores both code and data, which means the cache management has to consider what code it wants to cache as well as the data, and this can impact performance. The cache may plan out multiple operations to fetch data into the cache based on how the program is accessing memory, so it's not really fetching one cache line at a time in many cases. Overall, the most challenging aspect is that there's no way to know what's actually going on in the CPU. We can only try to understand some basic guidelines and then test our code to see if those guidelines improve our algorithms. It was also pointed out that the Go compiler might optimize away certain steps, leading to performance improvements that had nothing to do with the CPU cache. I did some work to investigate that, and it doesn't seem as if Go is doing additional optimizations that can be impacting the results. I was considering doing a complete retraction of the previous video, or completely reworking it with new tests. But after reviewing the first draft of this script, I decided it wasn't necessary. Nothing I learned invalidated that video, but it seemed worth making a follow-up video to fill in some of the details.